Since 1960, humanity has conducted hundreds of systematic searches for extraterrestrial intelligence, scanning millions of stars across billions of radio frequencies. The combined result of every observation ever made is 0 confirmed artificial signals. 0. The galaxy contains hundreds of billions of stars, and the most conservative credible estimates suggest that hundreds of civilizations capable of radio transmission should exist within detectable range. We have looked. We have listened. We have found nothing. This gap between statistical expectation and observational reality is the Fermi paradox. And one proposed resolution suggests that the silence is not because no one is there, but because every civilization that makes itself heard does not survive long enough to be heard twice. The Fermi paradox sits at the intersection of astronomy, biology, and game theory. Its key components are the Drake equation, formulated by astronomer Frank Drake in 1961, and the observational record of SETI, the search for extraterrestrial intelligence. The Drake equation is not a formula for calculating a precise number. It is a framework for identifying the variables that determine the number of detectable civilizations in the galaxy, the rate of star formation, the fraction of stars with planets, the fraction of those planets that could support life, the fraction that actually develop life, the fraction that develop intelligence, the fraction that develop detectable technology, and the average lifespan of such civilizations. Of these 7 variables, we now have strong empirical constraints on the first 2. The rest remain matters of speculation anchored to a single data point, Earth. SETI has been listening since Frank Drake's Project Ozma in 1960, when he pointed a 26-meter radio telescope at Tau Ceti and Epsilon Eridani. He heard nothing. In the decades since, SETI has expanded to scan billions of radio frequencies across vast swaths of the sky. Project Phoenix, the Allen Telescope Array, Breakthrough Listen, collectively, these programs have examined millions of stars with increasing sensitivity. The result is always the same: silence. Before examining what the silence means, we need to establish what counts as evidence and what does not. Tier 1 evidence in this case is physical and observational data, the number of confirmed exoplanets, the spectroscopic composition of distant atmospheres, the documented null results of SETI surveys, the age of the universe, and the mathematical parameters of stellar evolution. These are measurable, verifiable, and uncontested. Tier 2 evidence includes corroborated theoretical frameworks, evolutionary biology's understanding of how complexity emerges, game theory's analysis of strategic behavior under uncertainty, and multiple independent models of galactic colonization that converge on similar timelines. These are well established within their domains but are being applied by analogy to an unobserved phenomenon. Tier 3 evidence consists of single-source theoretical claims, specific proposed solutions to the Fermi paradox that have not been independently corroborated by observation. These include the dark forest theory, the zoo hypothesis, and various proposed great filter mechanisms. Not evidence, science fiction narratives, UFO reports that have not been verified as extraterrestrial, and the absence of a signal as proof of any specific explanation. Silence is a fact. What the silence means requires additional assumptions. 2 logical rules apply throughout. First, correlation does not equal causation. We cannot assume that because a condition exists on Earth it must produce the same outcome elsewhere. Second, absence of evidence is not evidence of absence, but it does establish an upper bound. If civilizations were common and loud, we would detect them. We do not. So they are either uncommon, quiet, or both. The anomalies that make this case resistant to resolution are 3. First, the observational record cannot account for the gap between the expected number of detectable civilizations, which, under even conservative Drake equation parameters, should number in the hundreds, and the confirmed number, 0. This is not a small discrepancy. It spans several orders of magnitude. The evidence establishes the gap exists, it does not establish what causes it. Second, the record cannot account for the absence of any technosignature or biosignature despite the universe being old enough for civilizations to have arisen, flourished, and left detectable traces many times over. A single civilization with a million-year head start on us could have built structures or signals visible across the galaxy. We see none. The evidence establishes the absence. It cannot distinguish between civilizations that never existed and civilizations that no longer do. Third, the record cannot distinguish between the great filter being behind us, meaning the improbable steps from chemistry to intelligence have already been surmounted, and the great filter being ahead of us, meaning a universal mechanism destroys civilizations before they become galactically visible. This distinction is existentially critical. The evidence establishes that we exist. It does not establish whether our survival is the rule or the exception. From Tier 1 and corroborated Tier 2 evidence, we can state the following with confidence. The evidence establishes that the galaxy contains billions of planets in habitable zones. It establishes that the universe is 13.8 billion years old. It establishes that no confirmed artificial signal or technosignature has ever been detected from any point in the sky, despite 6 decades of systematic searching. It establishes that, under the assumptions of the Drake equation, the expected number of civilizations should be significantly greater than 0. The evidence does not establish the value of any Drake equation variable beyond the first 2. It does not establish why the universe is silent. It does not establish whether life exists elsewhere. It does not establish whether any proposed solution to the Fermi paradox is correct. This is the ground truth. Every explanation must account for. A universe that should be noisy is quiet, and we do not know why. The attempt to resolve this paradox begins formally with Frank Drake's 1960 observation and the 1961 Green Bank Conference, where a small group of scientists including Drake, Carl Sagan, and others first formalized the variables that determine the likelihood of extraterrestrial contact. The Drake equation was never intended to yield a precise answer. It was a way of structuring ignorance, identifying what we would need to know to make a prediction. In the decades that followed, the first 2 variables were progressively constrained. In 1992, Alexander Wolszczan and Dale Frail confirmed the first exoplanets orbiting a pulsar. In 1995, Michel Mayor and Didier Queloz discovered the first exoplanet orbiting a Sun-like star. The Kepler mission, launched in 2009, ultimately confirmed over 2,600 planets and established that planets are the rule, not the exception. The galaxy likely contains more planets than stars. But the remaining variables, concerning the emergence of life, intelligence, and technology, have resisted empirical constraint. We have a sample size of 1. Life arose on Earth roughly 3.8 billion years ago, within a few hundred million years of the planet becoming habitable. This suggests the origin of life may not be the hardest step. But it could also mean we are looking at survivorship bias. If life had not arisen quickly enough on Earth, we would not be here to observe it. In 1996, the economist Robin Hanson formalized the concept of the Great Filter in an essay that asked a direct question: if the steps from dead matter to expanding interstellar civilization are as probable as the Drake equation's optimistic parameters suggest, then why do we see no evidence of any civilization completing those steps? Something must be filtering them out. The question is where that filter lies. The scientific consensus, such as it exists, favors explanations that place the filter behind us. The rare Earth hypothesis, articulated by Peter Ward and Donald Brownlee in 2000, proposes that while microbial life may be common, the conditions for complex multicellular life are extraordinarily rare, requiring a specific type of star, a specific orbital position, a large moon for tidal stability, plate tectonics, and a Jupiter-like planet to clear orbital debris. Each condition reduces the probability. Combined, they may make intelligent life a near-unique occurrence in the galaxy. This explanation has the virtue of parsimony. It requires no unknown mechanisms. It accounts for the silence by arguing that the silence is genuine. There simply are no civilizations out there to hear. The strongest evidence for it is the sheer number of improbable steps that led to human intelligence, each of which took hundreds of millions of years. The transition from prokaryotes to eukaryotes took roughly 2 billion years. The Cambrian explosion, the emergence of complex multicellular life, occurred after another 1.5 billion. These long intervals suggest hard evolutionary steps that may rarely or never be completed on other worlds. The explanation holds under scrutiny. It accounts for the baseline facts and the first two anomalies. Its weakness is that it extrapolates from a single data point. We do not know whether the long intervals in Earth's history reflect intrinsic difficulty or merely contingent circumstance. A sample size of 1 cannot distinguish between a process that is universally improbable and one that simply took a long time on one particular planet. The rare Earth explanation also struggles with the sheer scale of the galaxy. Even if the probability of intelligent life arising on any given planet is vanishingly small, enough planets exist that it should still happen many times over. But consider this before evaluating the alternatives. The rare Earth explanation and similar Euler filter solutions have one critical advantage: they do not require us to believe that something is actively suppressing civilizations. They explain silence through absence. The alternatives explain silence through concealment or destruction, and these require additional assumptions that must be justified by correspondingly stronger evidence. The most striking alternative is the dark forest theory, articulated by the science fiction author Liu Cixin in his 2008 novel of the same name. Despite its fictional origin, the theory has a rigorous game-theoretic foundation. The logic proceeds as follows. In a universe with multiple civilizations, two conditions hold. First, there is a chain of suspicion. You cannot know whether another civilization is benevolent or hostile, and you cannot verify their intentions at interstellar distances. Communication itself is limited by the speed of light, making real-time dialogue impossible. Second, there is a technological explosion. A civilization that appears harmless today may advance rapidly and become an existential threat tomorrow, on timescales shorter than the round-trip time for a signal exchange. Under these conditions, the rational strategy for any civilization that detects another is to destroy it immediately, not out of malice, but out of self-preservation. The cost of misjudging another civilization's intent is total extinction. The cost of a preemptive strike is merely the energy required to execute it. If every civilization in the galaxy reaches this conclusion independently, the result is a universe in which every surviving civilization is silent and hidden. Any civilization that reveals itself, through radio signals, atmospheric technosignatures, megastructures, becomes a target. The silence of the universe, under this model, is not the absence of civilizations. It is their survival strategy. The dark forest theory has no Tier 1 or Tier 2 evidence supporting it. No civilization has been observed destroying another. No confirmed technosignature has been detected and then silenced. The theory is a logical construct derived from game theory applied to a set of assumptions about interstellar civilization. Its strength is that it explains the silence without requiring the great filter to be behind us. It allows for a galaxy teeming with life that is simply too afraid to speak. It accounts for all three anomalies: the gap between expectation and observation, the absence of technosignatures, and the uncertainty about where the filter lies. Under the dark forest, the filter is not a single event. It is a continuous process of elimination. Its weakness is that it is currently unfalsifiable. Any observation consistent with an empty universe is also consistent with a dark forest. The theory predicts exactly what we see, but so does the rare Earth hypothesis. It also carries an implicit assumption that interstellar destruction is technologically feasible and energetically affordable for the attacking civilization across vast distances. We do not know this. To distinguish the dark forest from rare Earth, we would need evidence that civilizations exist but are hiding. A sudden cessation of a detected signal could support the dark forest, but it could also support a dozen other explanations. A megastructure that appears deliberately destroyed would be suggestive, but we have found none. What evidence would falsify the dark forest? The discovery of a civilization openly broadcasting, one that has survived its own visibility, would undermine it. But we have made no such discovery. A third category of explanations places the Great Filter ahead of us. Under these models, civilizations do arise commonly, but something destroys them before they become detectable on galactic timescales. Candidates include nuclear war, artificial intelligence, engineered pandemics, resource depletion, or some catastrophic technology we have not yet discovered. These explanations are consistent with the silence but share the weakness of the dark forest. They propose a mechanism we have not observed. They also carry an unsettling implication that our own civilization will face and likely not survive the same filter. What distinguishes the ahead filter from the dark forest is intentionality. The ahead filter proposes that civilizations destroy themselves. The dark forest proposes that civilizations destroy each other. Both explain the silence. Neither has empirical support beyond the silence itself. And the silence, as established, is consistent with all three categories of explanation. The question of why the universe is silent remains open. But the structure of the problem tells us something important about what a resolution would require. To determine whether the Great Filter is behind us, we would need to discover life, any life, on another world. Finding microbial life on Mars, or biosignatures in the atmosphere of an exoplanet, would demonstrate that the origin of life is not the filter. Finding complex life, or the ruins of a civilization, would push the filter further down the chain. Each discovery would narrow the space of possibilities. This evidence does not currently exist, but the technology to obtain it is under development. The James Webb Space Telescope is already probing exoplanet atmospheres. Future missions may provide the data we need. To determine whether the dark forest or an ahead filter model is correct, we would need to detect a civilization and then observe what happens to it. This is a fraught proposition. The dark forest theory's own logic suggests that broadcasting our presence is an existential risk, a claim taken seriously enough to prompt ongoing debate about whether active messaging extraterrestrial intelligence should be conducted at all. The evidence that would falsify or confirm the dark forest is, by the theory's own structure, evidence we may be unwise to seek. There is a deeper limitation. We are trying to answer a question about the behavior of entities we have never observed, using a dataset that consists entirely of our own civilization and our own planet. This is inference from a single point, and it is intrinsically fragile. Any conclusion we draw, whether the filter is behind us, ahead of us, or standing in the dark watching, rests on assumptions we cannot currently verify. The silence of the universe is the best documented fact in this case. What it means is the least certain. The fermiparadox does not prove that the dark forest is real. It does not prove that civilizations destroy themselves. It proves only that the universe is quieter than our models predict, and that we do not yet know why. The most honest answer to Enrico Fermi's question is the one he gave himself in 1950, over lunch, before the conversation moved on: we simply do not know. But we should be clear about what we do know. If the filter is ahead of us, the silence is not empty. It is full of civilizations that learned, too late, what the universe expects of them. And if the dark forest is real, then the most dangerous thing a civilization can do is what we have been doing since the invention of radio, shouting into the dark and waiting for an answer that may never come, or may come from something that prefers we stayed quiet.